Good morning, everyone. So, as we come to know that till last class we have been studied what is atmospheric refraction and various examples of atmospheric refraction in our daily life, like twinkling of stars and how the stars are appears to be far away than the actual position, advanced sunrise and delayed sunset, and as well as also we have been studied what is the formation of mirage. Is it as guys? So the same way we are going to study the next phenomena of light, that is called as scattering of light. So what is scattering of light, how the scattering of light is taking place, that is all the things we will discuss in this concept. Now first let us comes to know what do you mean by scattering of light? So as we know that light means what? Light is a form of energy. Is it yes or no, guys? Yes or no? Light is a form of energy. So now, or else which will make us to give a sensation of sight is called as light. Now, what do you mean by scattering? That is what we want to know. So forget about light. Light we are studying from the first chapter. So coming to the here, scattering of light, or we can say scattering means the sense of just whatever the light coming from the source, it will divert it to all the directions. That is what we can say. Throw in the various random directions. That is what we should call it as scattering. Scattering means if the light is coming from the source, it will throw it into the different directions randomly. That is what we should call it as scattering. What we should call it, guys? Scattering. So, scattering means what? Scattering of light means.
The light is
So throw.
light coming from sources
Throw light
randomly.
Throw light in various random directions. Random directions is only called as scattering of light. So if you'll observe here, the light is scattered when it falls on various types of suspended particles in its path. So when the light is coming here, suppose for example, if the light is coming in this direction, so now because of the particles in its path, it will divert into random directions. That is what we should call it as scattering of light. Do you understand? So when a particular path, if the light is coming, because of the suspended particles in its path, light will
Tindal Effect. The Tindal Effect.
Random directions. That is what we should call as scattering of light. So here, this scattering also depend upon the particles. Suppose when the light is traveling in this path, sometimes maybe bigger particles are present. When the light is traveling in this path, sometimes maybe smaller particles are present. So based upon the size of the particles also, the scattering of light is varies. Do you understand, guys? So when you can take here, light is scattered how? Only when it falls on the various type of suspended particles. Suspended particles means if the light is traveling across the atmosphere contains suspended particles. So because of that suspended particles, light is traveling into the random directions. That is what we should call as scattering of light. Do you understand? So on these suspended particles may be bigger or maybe smaller. So the scattering can be, understand, the scattering of white sunlight. For example, if you take colored lights which makes up the white sunlight. So if you take, for example, as we know that sunlight, what is the color of the sunlight? What is the color of the sunlight? Sunlight is in white color. Yes or no?
White.
So,
White color.
Sunlight is in white color. If you take the scattering of this white sunlight or if you take any kind of colored lights which make up the white sunlight, everything because of what? Scattering. Understand? We can do the scattering. So everything is because of depending on the size of the particles. Maybe the particle size is smaller, the particle size may be bigger. So we will study. The size of the particles increasing, scattering, what will happen? If the size of the particles is decreasing, what about the scattering? If effect increases or decreases, we will discuss it. So you can take here everything like a white light is scattering or a colored light which will make up the white light. All this their scattering is depends on the size of the particles which are suspended in its path. So now you can take here.
It is also known as Tindal Effect.
For example,
Tindal Effect.
yeah, in this scattering of light only, if you'll observe, always you can look into the sky. The sky is appears to be what color? Sky is appears to be a blue in color. Is it yes or no? So why the sky is blue color, and as well as you can see a red color of the sun during at sunrise and sunshine. You can see surrounding by the sun and as well as sun is very reddish color during sunrise and sunset. Is it yes, guys? Yes or no?
Sir.
Yeah.
Yes, sir.
This all like how the skies appears to be blue. Same way, how the sun is red in color during sunrise and sunset, and as well as you can observe this all the things explained only on the basis of what? On the basis of scattering of light. Scattering of light caused by Kumra, caused by Earth's atmosphere. What is that? Atmosphere. So because of Earth's atmosphere means what? Atmosphere means water. What do you mean by atmosphere? Atmosphere means air. Understand?
Blanket of earth surrounded by the earth.
Atmosphere means air only. Because atmosphere means a thick blanket of air. Correct or not? So this thick blanket of air means what it contains? It contains a mixture of gases. What is that?
Gases.
Mixture of gases. So when, as we know that it contains even suspended particles like dust particles. So the type of dust particles present in the atmosphere. So based upon that, the scattering of light will be varies. It may be a big particles are suspended or maybe small particles are.
Dust is a particle, sir.
What?
The dust is a particle, sir.
Yeah,
The particle is dust.
Dust, not only dust, even nitrogen, oxygen, also the particles only. So that is why you can see some kind of water bodies. We used to see the different kind of colors, like they are in red color, green color, like the different colors are various colors are forming, like natural beauties. So that is all happening when the light strikes the major parts of nitrogen particles or major parts of oxygen particles, like that it is. Understand, Gardigaya? Okay.
Yes, sir.
Yeah. So all these phenomena, all the natural phenomena like sky is blue in color during sunrise and sunset, how the sun is appears to be red during afternoon time, how the sun is appears to be white. This all the things is because of scattering of Earth's atmosphere or scattering of Earth's air, the air which is present in our surroundings. So that is what we should call as scattering of light. So what do you mean by scattering of light? Just the light which is coming in a particular
The light
The-
throw light is one random direction.
Throw light in various random directions because of humra, because of the suspended particles present in its path. That is what. So that is what we should call as scattering of light. Now, first example which we will study, we will describe the first one is Tindal Effect. So this is not new to you, which you have been studying in class 9th chemistry. The first effect of because of scattering of light, we will study Tindal Effect. What is this? Tindal Effect. Okay. So now let us start with all of you keep heading Tindal Effect. Tindal Effect. Shall we start?
Yes, sir.
Yeah. So What do you mean by Tindal effect, and what is the examples of Tindal effect in our daily life means? So if you'll observe very carefully, Tindal effect means the scattering of light by particles in its path is only called as Tindal effect. So the particles which are present in its path of the light, in path of the light, they will scatters the light. They will scatters the light means they will send the light in the random directions. That is only we should call it as what? Tindal effect. Understand? The scattering of light by particles in its path is only called as Tindal effect. Please write it, all of you. The scattering, SCATTERING, the scattering of light by
particles in its path.
Suspended particles.
Yeah, by particles in its path is called Tindal effect. It's called Tindal effect. So now, if you'll see, when a beam of sunlight, for example, you can see, I will show you the pictures, real pictures you can understand. So most of you can see early morning, while the sunlight is entering into our bedroom or else our house, you can observe, we are able to see the clear path of the light, not normal thing. When the light is falling at a certain angle at the morning time alone, we people can able to see the dust particles inside the atmosphere. Normal time it is not visible. Have you seen it? Please tell me.
Sunlight as well.
Yeah, sunlight enters into dusty room. Dusty. Understand? Basically normal room also, dusty room. As you know, when you are
Because they have the particles.
when you are sleeping, you can see when the light is entering to your bedroom, you can able to see the clear path of the light. For example, when it is coming from the pinhole of some particular window or something, so I can see the very clear path of the light. I think you maybe have seen it already from your childhood. So you maybe see the normal, when the light is coming normally, you maybe people not notice. But when the light is coming during morning time, you may be having noticed that the clear path of the light will be visible. So for example, you can see, have you seen it, guys? Please tell me. So this is what? You can see, notice here, sunlight enters into the dusty room. You can able to see the clear path of the sunlight by this time. Like that is what we should call it as.
Then forest, sir.
Yes. That like forest, it is okay. Forest, it is in our class 9th also. For just I am saying, you can see the sunlight enters into this dusty rooms through a window or somewhere. For example, you can observe here in this picture, the light is coming through the window. Now you can see, we are able to see the clear path of the light. Have you noticed it? Clear path of the light. I think you guys not seen this? I have noticed in my home so many days when I'm in kid. You people are not noticed anytime? At least anybody? Have you noticed it, Arya?
Yes, sir.
Yes, sir.
Yes, sir.
That is what we should call it as Tindal effect. So if you observe here, when a beam of sunlight, what do you mean by beam, Ra? Why I am calling here beam of sunlight? Because a white light is a mixture of light. White light is a
Seven colors.
Seven colors.
It is a beam of light. Understand? So a beam of sunlight enters into this kind of a dusty room through a window or else any opening of our home or somewhere, then the path becomes visible to us. So why? So at that time only, at that angle only, when the light will fall, then only the path is visible to us. So because the tiny dust particles present in that air of room, they will start scatters the beam of light in all around the room. So when the light is coming from that a window or somewhere, then it will enter into like this. So the dust particles which are present inside, you can see, they will start scattering the light into the each and every particle. They will start scattering the light into all the random directions, and you can see I used to play with this also by keeping my hand for disturbing these particles. I used to keep my hand middle and I try to make some disturbance, but still the path of the light will be like that only. And you can clearly notice the dust particles, how they are floating inside there. Is it yes or no, guys? Yes or no? So that is
Yes, sir.
so these tiny dust particles, listen very carefully. These tiny dust particles, they will scatter, which are present in this air. They will scatter the beam of light in all around the room. So that is why when the scattered light enters into our eyes, they will scatter the light all the directions, so that light will enters into our eyes. So then only you can see, we can see a beam of light. But we can able to see? We can able to see a beam of light. That is what we should call as scattering of light. What we should call, guys? Scattering of light. So this scattering of light is only what we should call Tindal effect. What we should call?
Tindal Effect.
Understand?
Tindal Effect.
So, because of the tiny dust particles which are present inside our room, they will scatter the light in random directions and they will make us to send the light to our eyes. That is what we can able to see, a beam of light. So, seeing this beam of light, because of the tiny dust particles which are scattering the light, is only known as what we should call Tindal effect.
Tindal Effect.
Tindal effect. So this is the example of Tindal effect. So if we take this, the Tindal effect is the way of a beam of sunlight becomes visible as it passes through the dust particles in the air. Dust particles in the air of a room. That is what we should call as Tindal effect. Understand, Ra? So if you'll observe very carefully, the best example of Tindal effect, what is the best example? What is the best example? The sunlight, a beam of sunlight enters into what? Enters a dusty room through a window. Its path becomes visible to us. Because of whom, Ra? Anybody? Because of whom? How it will be visible? Because of why? Arun Karthikeyan, Varshini? Because it contains
Because the dust particle randomly divides the light, sir, into our eyes.
A dusty room contains what? A suspended particles of dust. So these particles will scatter the light in all the directions randomly. That is what we should call as Tindal effect. Understand?
Tindal Effect.
Like that, if we'll take that, this is the first example. Like if we'll take the second example, which is not new to you, we are studying from. Good morning, Jesse. You can call to absentees. So if we'll take the second example, you can see also the sunlight passes through a canopy of dense forest. You can observe this picture. What do you mean by canopy? Means like a very, very big trees, like you can see in Cherrapunji in our India, highest rainfall rate. Is it yes or no? As I think second highest rainfall rate now. So there the forest is very, very like Haryana. If you go, situations like a forest continuously most of the days rain. So always the atmosphere contains this kind of moisture and all. So there the thick forest, the forest leaves and all are very, very big and they're tired. Means the forest trees are very, very longer in size, height. So if you observe there between the leaves gap, understand when the sun is rising during morning, you can see the Tindal effect we can observe when the sunlight passes through this canopy. What do you mean by canopy? the thick, understanding, the thicker part of the topmost part of the
Forest, sir. Thicker part.
understanding. So the top part of the forest is only called as canopy. So through this canopy of a dense forest, what do you mean by dense forest? Anybody? Means more thick forest. Okay. So dense forest, when when the light is enters through this gaps between these leaves, you can observe here. So that I am saying dense forest. Dense forest means highest rainfall or lowest rainfall? More rainfall or
Highest rainfall.
ah?
Highest rainfall, sir.
More rainfall.
Dense forest means more rainfall. So more rainfall means it contains more water moisture or less water moisture. Means it contains more water droplets, or atmosphere contains more moisture or less moisture. More moisture. Is it a
More moisture.
So atmosphere contains more moisture. So these tiny water droplets only, like what you have been studied, formation of rainbow. The same way, the tiny droplets, water droplets in the mist, like in a sense of always like a snow, something is falling. We know that mist is a one kind of a snow. So in that mist, they will start scattering the light. That is also, we can say, one of the example of scattering of light. Is it yes or no? So the Tindal effect. So the scattering of sunlight passing through the canopy of a forest is happening because of what? Because of a tiny water droplets in the mist, which will scatters the light. What they will do? They will scatters the light.
That's
Understand?
also particular, sir.
Yeah. So the tiny water droplets which are present inside this moisture, that inside that atmosphere, they will act like a dust particles, like a suspended particles, and they will start scattering the
The
light.
milk is also a colloidal solution, no? So that also will
Milk
have a Tindal.
colloidal solution. So milk also, the path is visible to us if you'll pass through that. That is what you have been studied in the class 9. Is it yes, guys? So if you'll pass the light through the milk, so it is also make us to see the clear path of the particles, because milk is a colloidal mixture. What is that? Milk is a colloidal mixture. So each and every particle will scatters the light in the random direction and make us to see the clear path of it. That is what we should call as Tindal effect. Understand? So the second example, what is the second example of Tindal effect? A sunlight passes through the canopy of a
Canopy of dense forest.
Forest. Dense forest.
sunlight passes through the canopy of a dense forest. Canopy of a dense forest. So here, who will act like a suspended particles? The water droplets. Understand, Ra? The tiny
Yes, sir.
Tiny
water droplets. So always in the dense forest means that this kind of regions, who will be there? Mist is covered in the atmosphere. Mist is a type of snow kind of thing. So water droplets in the mist, they only will scatters the light. So like example, if we take note, all the colloidal mixtures are examples of what? Examples of Tindal effect. Tindal effect means what? Scattering of light. Do you understand, guys? So everything is called as Tindal effect. So that is all called as scattering of light. Is it understand? What?
Can you show the first point, sir?
Yeah, I will show. So this is the first point. So sunlight enters to dusty room through a window. This is the basic one which we people will observe in our home. Most of the days you can notice it when the sunlight is coming through a small hole from your bedroom window. When you are lazy to wake up, like 7 o'clock, 7:30, if you wake up, you can see that which is coming. Light is coming from the window. Do you understand, Ra? So that is the first one, and this is the second one. Like that, so many examples you can take. understand, like milk, what Kevin said. Class 9th, you have been studied examples of colloidal substances. So all the colloidal substances are examples of this Tyndall effect only. So everything, they will scatters the beam of light. So if we'll see, as we have already studied in the last class, scattering the spectrum of sun's white light, which consists of how many colors? What do you mean by spectrum? Anybody? What do you mean?
Colors, sir.
Spectrum means how much? What do you mean by spectrum, Dina?
Band of 7 colors.
A band of
Formation of 7 colors.
colors.
What color?
Band
Yeah.
of 7 colors.
Colors. Band of
7 colors.
7
Calls
colors.
with GR.
Spectrum. So as we know, every white light, it may be a light coming from the bulb or maybe coming from the sun. Everything is contains what? Everything they contains 7 colors. Is it yes or no?
7 colors.
Is called as a band of 7 colors. So if you look at the spectrum of white sunlight, spectrum of white sunlight means how many colors? Band of
7 colors.
Band of
sir.
7
7
colors.
colors.
Band of 7 colors.
Yes. So let me take a band of 7 colors. Now you will observe. For example, I am saying. So let me imagine this all are called as 7 colors. What they are called as? VIBGR. VIBGO. Speak. VIBGO. VIBGOR. One more thing should come. Correct?
GY, sir.
VABGYOR.
GYOR.
GY, correct?
Yes, sir.
Yeah, GYOR. So in this VIBGR, so what is the top color? Top color is red and the bottom
Red.
was violet.
Violet.
Bottommost color is violet.
Yes, if you look at the spectrum, of white sunlight, we will observe red and blue colors. You understand very carefully. What it is? The red and blue colors are very predominant in it. What do you mean by predominant? Anybody? What do you mean by predominant? Red and blue colors.
Common.
Violet. Understand? Red and blue colors are most important. So that is why I said you. So when you look into the spectrum of white light, like rainbow also, major colors which we can observe, even though the violet is lowest frequency, but we can able to see the blue colors more because the amount of blue light is present in the rainbow is more than the violet light. So we can able to see blue color is the most predominant color. So what do you mean by predominant? Anybody?
Important.
Important. Yeah. Predominant means which having highest priority or else major portion of them they are only occupying. That is what we should call as a special importance is called as predominant light, which are more than other things. So if you'll observe here the red color light. So why I am talking about red color and as well as blue color only. So whenever we are talking VIBGR means remaining all the colors, the percentage in the rainbow is less. Only the dominant colors are red and blue color. So now if you'll observe here, as we have already studied, let me see, somebody should say red light. What is the phenomena of scattering of light? White. What is the wavelength? It is having longer wavelength or shorter wavelength? Anybody?
Shorter.
Red light is having shorter
All
wavelength.
will have a shorter
Shorter
wavelength. sir.
wavelength.
It's a shorter.
Green will have a longer wavelength.
Longer wavelength. Understand? Red light is having longer wavelength. That is why it will run very faster. Is it yes or no? It will travel much faster compared to the other colors light. Is it yes or no? So red light is having longer wavelength. Again, I'm saying you most important MCQs these are. So red light is have a longer wavelength, but blue color light is having what? A shorter wavelength. What is that?
Shorter.
Shorter wavelength. So if you observe here, understand? So even for example, I'm saying, for example, if you take the wavelength of the red color is, for example, Example, I'm saying the wavelength of red color one is, suppose for example, if you imagine 1 meter. Example, right? Not I'm saying exact value. So if you take the wavelength of red color light is 1 meter, then the wavelength of blue color light is almost half. So half means how much? What is the wavelength of blue color light? This is the red color light. What is the blue color light? I'm saying it is like almost half. Half means how much? Half means how much?
1 by
2 meters.
1 by 2 meters.
Yes or no? Yes or no? That is what it is. So the wavelength of red color light is almost, it is longer than the blue color light. So blue color light is how many times? Almost half of the wavelength of the red color light.
Half of the wavelength of the red color.
MCQs. Understand most important reason assertion and as well as MCQ. So please all of you write it. So red light is, this one you can note it down. Red light is having longer wavelength and blue light is having what? Shorter wavelength. What is that? Dilipan? Shorter wavelength. Understand, Ashika? So how much it is? How much it is, Ra? So you can write it. Almost it is. The wavelength of blue light is, please note it down. Wavelength of blue light is almost half that of the red light. Is it okay, guys? Half that of the red light. Please note it down. Is it okay, Ra? All of you respond me.
Yes, sir.
Yes, sir.
yes, sir.
Observe very carefully. So, based upon this phenomena, understand? So, how the sky is appears to be blue. So, with the help of this one, because of this wavelength, the shorter wavelength of the blue light is almost like half of that of the red color light. So, with the help of this fact, understand? The wavelength of blue light is almost that of the half of the red light. So, in 1859, with this only, in 1859, so some scientist has been make an attempt to explain the blue color of the sky. That is what you can say. Understand, Ra? Tindal discovered that when white light consists of 7 colors is passed through a clear liquid, it's passed through a clear liquid having small suspended particles in it, then the blue color of white light is having shorter wavelength and it is scattering much more than the red color having longer wavelength. That is what he has been found. So who has been found, Ra? First, this one in 1859. What is the scientist name? The scientist name called as Mr. Tindal. What is his name, Ra? Mr. Tindal. That is why it has been called as, you may understand, that is why it is called as what? Tindal Effect. Called Tindal Effect. So, Tindal has been discovered. He has been taken as some kind of a clear liquid which contains what? Small suspended particles. What is that? Small suspended particles. You have to respond me. So, and he has been passed the white light which consists of 7 colors, and when the light is passing through these particles, he has been found it. He has been, what he has been found, Ra? He has been found the blue color of white light having shorter wavelength is scatters much more. Do you understand, guys? So the blue light is scattering much more into the random directions, all the directions. Yes. So the blue light is scattering. He has been found the blue light is scattering randomly. Most of the blue light is in all the directions compared to the what? the red color light which is having longer wavelength. So this most of the light who is scattering the blue light. Understand? Blue light is scatters is more than the red color light which is having longer wavelength. So that is what the phenomena he has been said. This is why how the nature is also happening. That is why the sky is appears to be what? The sky is appears to be blue in color. So because of the shorter wavelength he has been found, because of the shorter wavelength of blue light, it is mostly it is scattering away from it, and compared to the red light which is having longer wavelength, it has been much more scattering much more than the red color light. That is so the blue light has shorter wavelength, so